First of all, welcome to this Science Week webinar, the theme of which is Choosing Our Future Life with Intelligent Machines. I'm one of your co-hosts today. My name is Martin McHugh. I'm the Education and Public Engagement Officer with the SSPC. The SSPC is the Irish Research Centre for Pharmaceuticals, and we look at every aspect of pharmaceuticals from drug development all the way through to manufacturing. We have over 100 researchers in various different institutes all across Ireland, all across the country, and we work with industry. One of our partners, which you might have heard of recently, is Pfizer, especially with the COVID vaccine. So it's great to get some good news in 2020. Another one of the co-hosts there is Sean.O'Brien. Sean, you can give people a wave there. Sean is the Education and Public Engagement Manager with Confirm. They are a research centre that is built around smart manufacturing. They're hosted in UL, like all of the centres that are being talked about this evening. They have over 160 researchers with 8 sites around Ireland, and their aim is to transform manufacturing and industry into something that is really super modern with high-level, high-paying jobs. Things that they work on are, robotics, things that we're talking about this evening, artificial intelligence, networking systems. And it's, Confirm is built on 5 key pillars of excellence and ambition, impact, creativity and innovation, stakeholder engagement, and diversity and integrity. So it's great to have them on board, and it's great to have Don on board, who's going to be speaking this evening. Finally, then, last but not least, the last co-host is Claire McInerney. So Claire, you can give people a wave there. Claire is the Education and Public Engagement Manager with Lero, which is the Science Foundation Ireland Research Centre for Software. And they work with expert software teams from all over Ireland, between universities and institutes of technologies. They work in a wide range of things, from cool things like artificial intelligence, driverless cars, fintech, smart communities, software for healthcare, and so on. They work with 11 other sites across Ireland. They're hosted in UL. And as a researcher sort of in this space, when you think software, Lero is the first thing that comes to mind. So that's enough of that stuff, and enough talking about the co-hosts and so on. We're the people that are going to be in the background. It's time to talk about some of the more interesting people, some of the expert panelists that we have on this evening to talk about, machines in our lives moving forward with machines and technology. So the first person I'll introduce is Donna O'Shea. Donna is a researcher with Confirm Smart Manufacturing and CIT. So Donna, I'll just ask you to maybe say a little bit about yourself and a little bit about your research.
Thanks very much, Martin. I'm delighted to participate in today's session as part of Science Week. As already indicated, my name is Donna O'Shea. I hold a professorship position as chair of cybersecurity in Cork Institute of Technology, and I'm also co-principal investigator in the Science Foundation Ireland Research Centre Confirm, and I'm also a funded investigator in the SFI Research Centres Connect and Enable. And I'm group lead of a research group called REAV, which focuses on artificial intelligence and cybersecurity. And I also lead a national funded project by the HEA called Cyberskills, which aims to address the critical shortage of cybersecurity professionals across Ireland. And this project is in collaboration with UL, UCD, TU Dublin, and IT Tralee. My own research expertise and background is really in the area of enterprise network and service management, cybersecurity, where I look very specifically in the area of the design, analysis, optimization of wired and wireless communication systems, networks and services. I worked in IBM as well on various telecommunications, network and service quality and cybersecurity management products. Since 2013, I returned to CIT, and I've worked in various roles such as lecturer, and I was also previously head of Department of Computer Science and am now chair of cybersecurity. I'm very passionate about supporting and encouraging women to participate in computer science and cybersecurity. And my message and mantra is always that cybersecurity is a career for women and coincidentally men. I'm also director for IT at Cork, a not-for-profit organisation, and an IEEE senior member. So that's a summary. Thank you.
Perfect, Jen. We really appreciate you taking the time coming on board with an outreach event like this evening. So moving on to Luis then. Luis is an academic with the SSPC and a lecturer in the University of Limerick. Luis, could you give us a little introduction to some of your work?
Yeah, sure. Thanks, Martin, and hello, everyone. Yeah, so as Martin, as you have said, I'm a lecturer and course director of the Industrial Biochemistry program at UL. I'm also an SSPC funded investigator, and I'm a PI in the Bernal Institute. Now, just to give a brief overview about my background, I'm originally from Portugal, from Lisbon. I did there my bachelor's degree in biochemistry about, well, I suppose 14 years ago. Then I did my PhD between Portugal and Sweden. I worked, a short duration of time in the pharmaceutical industry. Then I came to Ireland, to SSPC about 6 years ago. So I'm a lecturer since over the last 3 years. In terms of research, my research interests, they focused on pharmaceutical manufacturing and biopharmaceutical manufacturing. So focusing on developing new pharmaceutical process for the production of pharmaceuticals and biopharmaceuticals, but also optimizing existing ones. So as a very much a focus on what the pharmaceutical industry is looking for. So I developed these new manufacturing process, and most of them are for generation of drug nanoparticles with improved properties to improve the bioavailability and the drug efficacy of medicines. But also I focus on developing existing drugs themselves, developing, improving their physical chemical properties. So it's a combination between process development, but also improving the properties of drugs. So that's a brief overview about my research interests.
Perfect. Thanks, Luis. We really appreciate you being on the call as well. And then over to last but not least, we have Connor Ryan, who is a researcher with Lero, and you're also based in UL as well, Connor. Is that correct?
That's right. So thanks for the invitation, Martin. So I'm a professor of machine learning at UL. And just to give a bit of background, I did my PhD in machine learning in UCC back in the 90s. And I'm the inventor, along with two of my PhD students, of a system called grammatical evolution. And this is a machine learning system that can automatically write computer programs. So you can basically specify a task that you want to have done, and our system, GE we call it, can automatically produce a program that'll do that task. I was a Fulbright scholar at the Computer Science and Artificial Intelligence Lab in MIT in 2013. The co-founder of a Limerick-based startup called NV Endurance that used machine learning to extend the life of flash memory. And flash memory is the kind of memory that you have in your phones. So your beloved cell phone that's covered with, that has all your photographs in it, all that stuff is going to die away at some point in the next couple of years. And our technology was designed to try and make that flash last longer. Now I lead a group of machine learning researchers in UL, and we work on everything from designing the next generation of machine learning algorithms to applying them to things like cancer detection and automatic generation of digital circuits.
So as you can tell from the three panelists, there's a broad range of expertise here, and definitely going to be able to cover the topic in depth about what the future is going to be like from your various areas of expertise. Just for the audience, we're going to go for about another half an hour on top of what we've already done. We'll have about 20 minutes at the end for questions, and there's a Q&A section in Zoom, so you can type in questions there. Like I said, myself, Sean, and Claire will be moderating, so throw in any questions and we'll ask your questions towards the end. So to start off the session, really, I'm number one with the first question, and it's really when you think about technology and you hear the term robot and machine. And when you say robot and machine, it's really informed by things like science fiction and by movies. But going to Donna first, I suppose my question to you is, when you hear the word robot or machine, what is it that comes to mind?
Yeah, I think when I think about robot and machine, I recall, Arnie and the movie Terminator. I used to think of robots in this manner, and in some ways I still do. But now I think about how robots and machines could potentially make my life easier. And I suggest that you look up this amazing robot called an iRobot Roomba. It's a vacuum cleaner that's equipped with an intelligent room mapping software, leveraging a low resolution camera that has ability to empty its bag, one full of dirt, and actually recharge itself. And I imagine myself, after purchasing this fantastic vacuum cleaner on a Saturday morning with my feet up, having a cup of coffee, and I log into my vacuum cleaner app, select the room that I want to vacuum, and let it do its job. Of course, in order for it to do its job, I would have to get over my OCD of vacuuming. And the reality, of course, may be that the iRobot Roomba is actually doing its job with me following with my old vacuum cleaner behind it. And I have considered purchasing this amazing product and have contemplated even the possibility of getting over my OCD and love-hate relationship of vacuuming. But then my professional paranoia generally kicks in, and I start asking questions like, if the password in the iRobot is statically assigned, can I actually change it? Can I disable its Alexa voice activation features? Do I really want internet providers knowing how big my house is, how many rooms it has, how many days a week I actually vacuuming my house? And where is the information being stored? Is it encrypted? And what would happen if it actually got hacked? And do I actually run the risk of having a mad robot vacuum cleaner terrorizing my cat and actually tormenting my dog? And do I actually mind the vacuum cleaner surveilling myself and my kids? What would happen if the vacuum cleaner actually fell victim to a denial of service attack, rendering device useless and rendering my investment useless and my dream of peaceful Saturday mornings going out the window? So when I think of the word robot and machine, it doesn't necessarily default to this humanoid type machine taking over the world, but rather a practical device that performs tasks and assists me and everybody else in their everyday lives. And of course, there are a huge number of technical challenges that exist in developing these amazing, wonderful, technologically advanced machines. But I believe the bigger challenges are the ones associated with the human adoption and dealing with these machines at a society level, and the trust and security associated with them. So that's what comes to my head. I'm gone beyond Arnie into more realistic, practical implementations, but that doesn't say that my view is limited in the sense in that form. So yeah.
Well, I'm definitely still at the Arnie stage of things, so it's an education for me sitting in on this and helping out. But just to pass that over to Luis, then, obviously from your perspective, are there differences then when you think of the words, a robot and machine? What are your thoughts?
Yeah, well, I suppose the definition, I'm not sure if there's an exact definition about robots. I mean, certainly a robot is not the same as a machine. Now, if we think about a machine, like, is my dishwasher a machine or a robot? Is my car a machine or a robot? Now, if it's a machine because I instruct the dishwasher to wash my my plates and all the dirty dishes, and I instruct my car to drive forward, backwards, etc. Now, but that's a machine, but a machine does not sense its environment. And I suppose that a robot will sense the environment, will analyze, will process the information, and will act on it autonomously. So when I think about robots, I actually think about self-driving cars. I know there are a few prototypes on self-driving cars. They are not necessarily right now on the road, but eventually they will come up. And self-driving cars, I will think of them as a robot. They don't look like a human, but in fairness, a self-driving car will drive on its own, obviously following certain instructions, but they won't necessarily have feelings. They won't have a consciousness, but they will act and drive, and I don't need to instruct the car to stop when a person comes up, and that's a robot. Now we can think also of drones, like if I'm commanding a drone is a machine. It does not act autonomously unless if it's an autonomous drone which drives on its own, and that's, I would say, a robot, right? So, but I think the line which separates robots and ourselves is getting blurry, and I think it'll get more blurry over time. Especially with technology, advancing at such a fast pace. In 20 or 30 years' time, we might see some big surprises in terms of artificial intelligence and so on. So it's an exciting. I'm more positive than negative on those things. I really doubt, at least for a long time, that down the line that we will have robots who will think, who will feel like us, who will have a consciousness, and so I think that's still far away. That will eventually happen. I mean, we're not even sure why we are conscious of our world. Where does it come from? in our brain. So I think it will be hard to, before we understand where the consciousness from ourselves comes from, it will be hard for us to develop machines that can do the same as we do and think as we do.
Yeah, so perfect. So then I suppose to pass that over to Connor, then obviously to get your perception of the robot machine and the differences and so on, because Luis brought up a good point. Many people in the public see them almost as the same thing. What's your perspective on it then?
Well, to me, they're basically just tools. So, everybody's tried to identify their relationship with robots and machines in relation to Arnie. So as the Terminator. Now, for me, it goes way back beyond that. So, sorry, that's a cat that's causing a whole bunch of. This is my cat that was afraid of my Roomba. So the first machine I would have used was a Sinclair ZX81. So I've been using technology probably since I was 9 years old. So I've had a very different relationship with technology than most people. So to me, it's always just been a tool. And the tool has improved incredibly in the last 40 years. So, its capabilities have been fantastic, but it is just a tool to me. So I don't see any difference between, the Arnold Schwarzenegger robot and the robot that's building somebody's car. It's just a tool that does one thing, and that's really all I wanted to do. So it doesn't matter if it's, Alexa or my desktop. I still think of that as just an ordinary machine. Now, I did actually have a Roomba, and I didn't have any problem, not vacuuming the apartment anymore. Not that I actually did a whole pile of it to begin with, Donna. But interesting, the reason I don't use it anymore is because of the cat. So the cats had a uprising against the Roomba, and it was basically either us or the Roomba. So the cats ended up winning over the thing. The concern I have about computers, again, it echoes something that Donna was talking about, is the more people accept them and the more they trust them, the more we're letting big enterprises into our houses. So I don't have any particular problem with the machines or the technology. The problem I have is with the people behind them. So when you have somebody like Amazon who's listening into all of your queries, or you've Google who are watching every search that you do, now I'm helping them sell me more stuff. And of course, they're already very good at it. And I bought my Roomba from Amazon as evidence of that.
Yeah, so I think it's really interesting, actually, the fact that sometimes these discussions you can get people on board and they're super pro, let's say, technology and robots. So you brought up some excellent points already, all panelists, about some of the positives and potentially some of the negatives around it as well. But it's at that stage, so I'm going to pass the ball over to Claire, and Claire has the second round of questions then.
Yeah, so thanks very much, everyone. So Connor, you've really teed that up perfectly for my question, which is around kind of, I don't know if people have seen The Social Dilemma, but it's exactly that. It's the manipulation of us as human beings. So I suppose the question is then, there is this negative perception out there. So I'd like you to just maybe talk a little bit about, the positives in your research with machines. So maybe we can start with Luis on this one. So positives around, your interactions with machines.
Yeah, well, I suppose for my research, my current research or my future research, which are things that we are looking at the moment, which is when we are developing or we are optimizing a pharmaceutical process to produce, final drug products, tablets or pharmaceutical powders, we're trying to do in a way that the manufacturing process does not need as much, let's say, user interaction for us to work on troubleshooting or optimize the process when something goes wrong. So in terms of implementing analytical tools which can measure the product which is being produced and can act on the process to improve the properties of the product in case the product is coming out in the wrong way. So it can act on it immediately without having anyone being there observing and acting on it. So that's kind of, using machines like artificial intelligence and machine learning to learn how to operate with the process without any user interaction. So I think that's kind of the positive of the research. And then my research really focused on pharmaceuticals, and within the pharmaceutical industry, it's quite difficult for a drug to come out. There's a rough number which is about 90% of pharmaceutical drugs which go into clinical trials, they actually fail going to the market because out of millions of potential drug molecules, companies select a few of them, and they do preclinical trials, and as they go on to clinical trials, it gets narrower and narrower, and they discard a few molecules. And so I think for each molecule that goes to the market, it's about $1 billion that is being burned. So I think with machine learning, analyzing, let's say, millions or billions of pharmaceutical molecules on the list, and analyzing what are the properties of those molecules, which molecules do have less side effects. And so using machine learning to predict the outcomes of clinical trials before actually going to clinical trials, I think that will be a major outcome on that. And then we know that machine learning has already been used for developing vaccines for COVID-19. I mean, we knew about the outbreak which was identified in China in November or something, and then in March there were already a few vaccines which were in initial clinical trials. I mean, that's quite crazy. Think about 20 years ago, 30 years ago, will it have been possible to develop vaccines for a virus in such a quick turnaround? I think it's really using computational power and machine learning to really working side by side with humans and maximizing the synergistic cooperation in research.
Yeah, cool. And I mean, that's so interesting. And I guess it gives us a great opportunity as well for people to understand the importance of things like machine learning in other domains, because, everybody gets this COVID thing and we have the world's attention on it here. So it's really interesting to hear about that. So I guess the same question to you, Conor, the social dilemma stuff, how do we, get away from that?
Well, okay, so my background actually is machine learning. So, I've come at this from the point of view as somebody who's building the algorithms that in general other people will use. So, I started life as a tool maker. Now, where life started to get really interesting was when I started getting involved with experts from other fields. So initially it happened with people from the medical field. So, these are often people who have, colossal data sets, and they're longitudinal data sets, so it's for a cohort of patients going back many years, and nobody really knows what to do with this data. So what we try to do is get involved in projects where we're analyzing these data sets with a view trying to predict when somebody's about to develop some condition. So 2 projects that are going on at the moment in UL. There's one on breast cancer detection. So we're trying to preemptively identify when there's going to be an architectural distortion in a breast. So basically a suggestion that there could be breast cancer about to appear for somebody, that even an expert wouldn't see yet. And we can do this looking at, images and all sorts of other medical information about the patient that would be difficult for a human to keep in their head all at the same time. Another related project or similar project that we're looking at is related to lung cancer detection. So if in general in Ireland, if you go in for a chest x-ray, if there's anything unusual inside that x-ray, for example, like a lung nodule, you're sent to the hospital in Limerick, where for the next 5 years, you get a scan every 6 months, a CT scan to see, has this thing changed? Because it could be indicative of lung cancer. And of course, this is a hugely stressful thing for people to go through. So what we're trying to do with their data is identify as soon as possible, is this thing just benign? Is this thing just sitting there? Because of course, it turns out a lot of people actually have these lung nodules. It just hasn't been noticed by anybody yet because nobody's looked. So what we want to try and do is identify, is this person likely to need some treatment? So that'll have to happen as soon as possible.
Cool, thanks a million. I mean, they're really tangible examples that everybody's, waiting for and really excited about to see coming online. I mean, that's brilliant. I suppose, Donna, over to your side, I mean, we've had 2 really nice examples there of how machine learning is really having positive outcomes. Do you want to give us some info from your perspective on things, on your research?
Yeah, sure. Claire, thanks very much. I guess I look at machines from the same perspective as Conor and Lewis, but I also look at them in the actual physical machines, which is my robot, which is basically with sensors and actuators that's connected to the internet. And the robot basically is an application of what we call an Internet of Things type device. And this Internet of Things type device is simply a device that connects to the internet, and it has the ability to communicate with other things and with the internet, and basically transmit data, giving us a deeper understanding of how it actually works and how these things all work together. And they're, in essence, small machines. In Industry 4.0 and smart manufacturing, which is the area I work very much actively in, we look at combining the Internet of Things and relevant physical and digital technologies, including analytics and additive manufacturing and robotics and high performance computing and artificial intelligence and networking, to really kind of advance the smart manufacturing Industry 4.0 application space. And in this area, it is envisaged that it's going to have a huge disruptive impact across a range of industries. And, you know, it's going to help us solve some of the most pressing challenges that we face in society today, helping us to improve growth, productivity, reduce operational costs in energy, water management. Because in essence, Connor and Lewis's research in machine learning and artificial intelligence would be useless unless things are actually communicating and collecting data and enriching the algorithms that or supporting the algorithms that they're developing. And I guess I work very much in that area, but I work very specifically in the area of cybersecurity. And you know, there is no doubt that the Internet of Things is going to have a huge impact on our everyday lives, but they have made our digital environments much more complicated and difficult to secure. And in a recent Hewlett-Packard study, it demonstrated that 90% of devices in a commercialized IoT device environment actually collected one piece of personal information, which is a no-no. 80% of devices required passwords of insufficient complexity and linked, and 70% of devices use basically unencrypted network services. And this was not in a home environment. This was in a fully managed, you know, enterprise secure environment. And these security issues exist because the attack and threat surface of Internet of Things is so big, and the security needs to just go beyond the actual physical IoT device to include a whole broader ecosystem of interacting devices at the edge, at the core, and across the whole network. And then we have cybercrime, which is also really, really complicated and an additional dimension that I work actively in. We have criminal gangs that work in partnership with nation states. We have exploit kits that are basically sold by criminals that make it easier for those with limited technical knowledge basically to launch and perpetrate attacks from their bedrooms with little or no technical knowledge. And crimeware is sold, you know, as a service, providing 24 user support, dedicated discussion forums in multiple languages. And these attacks can be launched at low cost with high payoff. And in this environment, existing signature-based threat detection mechanisms, which is the way that nearly every threat detection and anti-malware software operates currently, is not going to work. And we're looking at machines such as artificial intelligence and machine learning and deep learning to, you know, advance our understanding and, you know, provide early detection and mitigation of these type of attacks. So the machines are actually supporting the machines to actually do their job. So they're the type of machines that I work with. And it's more the application of Connor's algorithms into cybersecurity. That's the space that I work.
Oh, that's really great, John. I'm glad you came to the positive spin at the end of that. So that's really good. And I mean, it's a challenging environment out there, but so thanks very much. So now, as someone else Sean is going to take over the next question. I'll hand over to him.
Yeah, thanks very much, Claire, and thanks again to the panel for the really interesting discussion so far. Just to remind the attendees that the Q&A is open, and we're going to actually move to audience Q&A after this particular round of questions. So if you'd like to ask any questions, please put them into the Q&A chat box there now. So I suppose Claire was just highlighted how Donna moved on to the nice positive spin there at the end. I'm going to bring it back to a slightly more conspiracy theory type of a question. So I suppose just looking at various, like, would say, sci-fi movies and how like science fiction in the popular media over the last couple of years, there's been kind of a focus on this idea of the technological singularity, where like technological advances go beyond our control and begin to kind of, I suppose, take over humanity a little bit. So I suppose my question to the panel is, first of all, in your opinion, could this happen? And if it could happen, do you think it could happen in the near future, basically? So I think we're going to go to Connor first of all for that one, please.
Okay, so thanks, Sean. So I'll start with the good news.
Good.
Okay, I don't believe it can happen. However, it's not all positive, right? So let me just give a little bit of context first. So there's two kinds of AI. So you have strong AI, which is what you're talking about, where you've kind of human-like intelligence, and that's kind of what makes up the singularity. And I genuinely don't believe that's going to happen, possibly not for hundreds of years, if ever. The other type of AI is called weak AI. And this is the kind of AI that I do. So it's basically you have an algorithm and it does one job. Now, this is all very positive, and it's what both Donna and Luis are using. So we have an algorithm, we train it on a piece of data, and it does a really good job. Now, we see this all over the place, right? So you see this, from Amazon, Siri, Facebook newsfeed, all these sorts of things. And they're very, very good. Okay, so when they're trained very well, they're way better than humans are at their job. And this is where it starts to get problematic, because they're too good at their job, because they just keep doing the same thing, and they can be exploited. And there's multiple ways they get exploited. So there's multiple ways our lives can be ruined by these things. So they can be exploited by bad actors who gain access to this information. And, we've seen it happen in the US election, where there's all sorts of insane news being posted around, and people genuinely believing it. And, we're all victims of confirmation bias. Facebook know I believe this, so they're going to keep pumping you information about it, regardless of where it's come from. So this, this has already happened. So we've crossed that point already. So this is why we're in trouble at the moment. There's other problems then is that, and this is caused more by incompetence than malice, that the programmers and the people who prepare the data sets are often the cause of problems. So the classic one is there's a recidivism, if I can pronounce that properly, data set from the United States that's actually used in courts, basically to determine sentencing for people who've already been committed or who've already been guilty of a crime. So this person will come back up for another sentencing for another crime, and they use this piece of software to identify, should this person be sent to jail or not? And unfortunately, it turns out it's extremely biased, because the data set it's based on is extremely biased. So this comes from the criminal justice system in the United States, which unfortunately is biased against certain races. So if you're a white person who's back up for some sort of sentencing, the chances are you're going to get away with it. If you're a black person, especially if you're a black man, you almost certainly won't. So this is the problem here, is that we have bad actors who will exploit these things, and we have incompetent programmers and data scientists who are providing bad data that's reflecting the biases that we already have in society. So the short answer is, don't be afraid of singularity, but be afraid of the systems that we already have in place, because it's already ruining our lives.
That's really interesting, Connor. It's great. It's actually great to know. I think that for people listening, that I suppose AIs aren't all knowing. They do kind of rely on the data that they're trained with. So Dana, I suppose the same question to you. What would your opinion be on the whole idea of machines or robots taking over the world eventually, or AI?
I guess, in my opinion, I think anything is possible. I guess I don't have the expertise to make a call on whether we have reached this point of no return. I certainly think people more intelligent and who had more expertise in what I have had very strong beliefs, such as Stephen Hawking, who certainly believed that humans who are limited by slow biological evolution couldn't compete and would be superseded, and that the development of full artificial intelligence could spell the end of the human race. And I guess this goes back to Connor's comment about, weak versus strong AI, that if we develop very strong AI, then maybe it potentially could have the ability to end the human race. Technology entrepreneur Elon Musk has warned that AI is our biggest existential threat. Again, that's his opinion. What I am confident in saying, and what I firmly believe, is that as a society, we do face a number of threats to our human existence. I believe that these include climate change, the threat of nuclear war, and maybe potentially AI. I know for me, the threat of climate change is the one that keeps me up in AI. Maybe machines and AI can actually help with this challenge. I also believe in another quote that Stephen Hawking once made, where he warned we are at the most dangerous time in human history. And he believed this because we now have the technology to destroy the planet we live in, but not yet developed the technology to escape it. And I believe as a society, unless we develop a level of maturity around technology and politics and security and artificial intelligence and economics and individual responsibility, I'm a very pessimistic person, then we're actually doomed to fail anyway. So I'm sorry, Claire, for going back to the pessimism. But I think that there are loads of challenges. And for me, you know, it's climate change. That's number one. The rest is not really on my agenda at the moment. I don't think, you know, Arnie is going to be popping out of the closet, whereas I think there are far bigger threats to our human existence at the moment than AI.
Great, thanks, Donna. And I'd say I'd speak for everybody when I hope that the Terminator doesn't visit any of our houses anytime soon. Luis, I'm going to go to you with the same question, please.
Yeah, well, I suppose, well, it's certainly difficult or maybe impossible to predict observing what has been achieved so far and what are the future trends. Now, artificial intelligence is not my expertise area at all. I'm trying to, in the future, to use that a bit in pharmaceutical production. Now, in terms of point of no return, yeah, Stephen Hawking said that about 3 years or 4 years ago. Well, in that regards, I've been reading a book or trying to read a book from a person. He is a professor of history in the Hebrew University of Jerusalem. His name is Yuval Noah Harari. His book is Homo Deus, A Brief History of Tomorrow. And in that book, I think the book was published 2016, 2015, something like that. In that book, he says that we are the last generation of Homo sapiens as we know it, because he says that he knows that he is likely to have grandchildren, basically, but he is not sure, the author is not sure that his grandchildren will have children, in terms of, you know, the technology is advancing so much that it will constantly will modify human bodies, you know, with chip implantation, genetic engineering, plastic surgery, you know, and having people wired to connect directly to devices, you know. So in the future, it might be that humans will have technology to transform and enhance their bodies. So I think that probably will be a big point on using technology and robots on that. Now, it's difficult to say whether we are on a point of no return or not. You know, technology has been growing and advancing exponentially, but it's hard to say whether we will reach a stage where, you know, robots will become conscious and will overcome humans. I think it's unlikely. It's likely that robots will replace some human jobs and will create others. You know, and there are things which are quite useful for robots to do, maybe the heavy things, the heavyweight things, the carry on, you know, boring, repeating, you know, tasks that humans don't need to do it, and we might be looking to other things. But I think in terms of point of no return, it might be the case, but it's difficult to speculate what will happen. So I think Connor made a good point in terms of it's very unlikely. It might be hundreds of years away if it's going to happen at all. I mean, how can we create life with consciousness if we don't really understand where our consciousness comes from? So that's kind of the point I'm making there.
Great, thanks, Luis. I think that's a really interesting idea there as well. Just to go back to what you said about maybe like the kind of bio implants and things like that. So it could almost be some kind of symbiotic relationship, I guess, between humans and machines, as opposed to the ones we see currently in science fiction and things like that. So that's kind of, thanks to everybody for everyone on the panel for that really interesting discussion. So we have some questions in the Q&A. Martin, do you want to take them, or I can?
Yeah, I'll see if I can see them here now. Yeah, so first one here is from MC, someone trying to be anonymous. It says, Connor, I like your overview of machines as tools, but if we have advanced autonomous machines, such as fully autonomous vehicles, do these machines have agency? I'm thinking this in terms of autonomous decisions that solely originate in the machine, and how this determines different degrees of complex agency, and could this lead to the machine personhood? What are your views on this? Nice, simple question to start there.
A nice, easy one. Okay, so thanks for the question. Now, I suppose, okay, I can see what you're getting at here. All the information is coming to the car, into the vehicle, the decision's being made there. But the fact is, the machine wasn't responsible for that decision. The person responsible for that decision was the person who programmed the machine in the first place. So that's where responsibility lies. Because one of the things that concerns me about autonomous vehicles is the amount of testing that goes on. You know, because at some point, somebody has to be responsible for when this thing, you know, when something goes wrong, we need to be able to establish, was it something that was completely unavoidable, or was it just some sort of error? And if the answer is ever, well, the machine made a mistake, then I just don't buy that, because the machine doesn't make a mistake. The machine does what it was told. This goes back to the weak AI stuff that I talked about. These things never make mistakes because they do exactly what they were told to do. Now, if they were told to do the wrong thing, or if they're given the wrong information or the wrong data set, now it can all go horribly wrong. But we can't be blaming the innocent machine for this, because it only did what it was told. We need to go back and we need to blame the person who programmed it in the first place.
Okay, perfect. And we have a little response there from MC. MC is Martin Cunneen. So thanks very much, Martin, for that question.
Hi, Martin.
So we'll pass it over to, do we have other questions there, Claire?
Yeah, there's a second question here. Machine learning is very good for decision making. Collective decision making is very important for teams of heterogeneous nodes, IoT, robots, objects, works together in the same environment to achieve common goal collectively and autonomously. 1, I am looking for example or scenario for collaboration and cooperation in smart manufacturing. 2, what is the difference between task allocation, task assignment, planning assignment in case of collaboration and collective decision making? And 3, how machine learning role empower collaboration of heterogeneous nodes? So who'd like to jump on that one? Maybe the first one, the scenario for collaboration, cooperation, and smart manufacturing. That'd be Donna, maybe.
Yeah, I mean, I can give an example. It's quite a robust question, Sahid. Yeah, I guess in the area of smart manufacturing, if you go back and you look at the production of a drug, and the production of a drug is very sensitive to environmental temperature changes, and the quality of the product that's produced at the end, a small variation in the actual inputs or the process, and can have a huge impact on the quality of the product being produced, and also it could mean life or death for the actual patient that actually consumes the drug. So there's very stringent quality procedures, and drugs are generally produced in batches. And as a batch is being produced, there are loads of sensors, and all the inputs are tracked, and the sensors collect data from IoT devices that are attached to robots. And collectively, these robots work together. They will stop the process, they will redirect the process, they will terminate the batch, they will track the process, they will, document the process, and they will document the batch being produced at the end. So all of these things and devices and sensors and documents and people and visualization, analytics, machine learning have to work collaboratively, autonomously, proactively, to produce the final product. And this is a vision for Industry 4.0. We don't have all the answers to enable this vision end to end, but certainly there are a lot of aspects that have already been, I suppose, advanced to a level where, parts of the vision certainly are realizable and implementable. So I think that's a scenario where you have humans, machines, sensors, AI, analytics, visualization, documentation, and actual consumption of the product that are all joined together. I think that there's the terms that you're asking here in terms of task allocation, task assignment, planning assignment. I come from a computer science background, and I work with manufacturing engineers, and even the word process is different in both domains. When I think of a task allocation, I might think of a software agent being assigned a task, and it may have its own individual thread of control and execution engine to complete that task from beginning to end. Whereas in smart manufacturing, when they think about task allocation, it could be an actual robot that picks up an item and takes it to another location. So I think that as a group of professionals, we need to understand the terminology that had been used across the domains, but certainly in software development, task allocation, task assignment, and planning are very software based in terms of something does a job, something's been allocated a job, something does a job, and it all forms part of a collective group of entities. The machine learning one, I use machine learning. I use research from Connor and Lewis. I don't develop advancements in machine learning, so I probably defer to Connor Connor's expertise into the third question, because my expertise in that will be very much application focused instead of advancing scientific research in that domain, if you get what I'm saying.
Do you want to jump in there, Connor, for that last one, the how machine learning role empowers collaboration of heterogeneous nodes?
Okay, well, I suppose it depends on what exactly we mean by heterogeneous nodes. So, I think one nice example of this would be autonomous vehicles. I mean, like many people, I have an inherent distrust of them, but the fact is they do work for the most part. But the reason they work so well is because there's all this heterogeneous information coming. So we have cameras that are watching, a certain distance up the road. Then we have other ones that are watching right in front of the car. There's also sensors then on the wheels. So these are all returning very different kinds of information. So there's an awful lot of information coming in, and it's multimodal information. So it's extremely, some of it is visual, some of it is just numeric. And this is where the machine learning really shines, because it's synthesizing all this information together, basically coming back with actions. Do I need to brake? Do I have a safe distance? Is this object that I've detected up here, is it a person? Are they likely to cross in front of me? Are my wheels spinning too fast? Do I need to slow down? All this sort of thing. So this is where it'll shine, is that they're getting information from different sources.
Yeah, so I think that one is wrapped up there. One of the interesting things you're talking about a little bit about the trust and the distrust, and there's a question there from Shabam. He's a PhD with SSPC, so I might pass this one to Luis, but it's an interesting question where he says that CT scans and MRI imaging of the inner body is something that is completely trusted. Whereas to him and to many others, an MRI machine is just a black box and he doesn't understand what's going on in the inside. So why is there an inherent trust in MRIs and these sorts of scans, but not in artificial intelligence, for example? And then when are we going to get to a point where we have trust in these types of machines? So I'll throw that one to Luis there.
Well, I'm not an expert in MRI, in the magnetic resonance imaging, but I suppose that what happens when someone uses MRI is that a doctor conducts an imaging test and inside the patient's body, and what happens is that the computer will then take all those signals and radio waves and so on, and will translate all those signals into a 3D picture, so that the user, the doctor, can actually look at it, and so we trust on that, so that we understand that the picture is a good representation about the real aspect inside the body. Now, when you're using a automated machine learning, you're actually, the essence is that you're doing that automatically, and you're scanning all of those images and by a computer. So I think that there's always this fear that a machine is not doing things correctly or is missing anything there. So I think it's not that there's a mistrust about using machine learning or machines to do that. It's just we, as normal people, we're not used to have those type of equipments in place yet. So I think we are still getting used to. I'm talking about ourselves when we go to the doctor. We feel comfortable when the doctor is analyzing us, and we trust in what he says. Now, a doctor can make things wrong and give bad judgments. And I think that if a program is very well developed, probably it will surpass in some ways what a doctor will say in terms of analyzing an image, for instance. Now, it's not my expertise on this, but this is what, on the top of my head, this is what I think of, about analyzing this type of images.
Can I add a point there as well? I have an active research project in collaboration with McKesson, which is a Fortune 6 company. It's one of the largest global companies in the area of healthcare. And we're looking at explainable AI to be able to look at early detection of cancer. And I do this with a team of AI experts as well. And I think the problem is that, for practitioners or for medical doctors, there's a black box operation of these AI models. And, when an AI model makes a decision about whether a person has cancer or not, the practitioner doesn't even know really the features or the impact of the features that were used to actually make that decision at the end. And for us, what we're looking at is visualization techniques to be able to support practitioners and medical doctors to say, right, yeah, well, okay, I get the operation of this, and I believe that the operation is trustworthy, and I'm happy that this algorithm is running as according to the way it's designed, and also to support further diagnostic testing. So if it says, right, well, it based its analysis or based its decision based on these set of features, but maybe a further diagnostic test to verify this might be beneficial to the actual patient, to minimize false positives, or to minimize inaccurate detection of cancer at an early stage. So I think that the use of explainable AI can also not be beneficial in healthcare, but also in areas that I work in more traditionally, in the area of telecommunications and cybersecurity, because network operators don't want all these false false alarms going off saying, there's a threat, or there's an attack, and then waking up a SOC analyst in the middle of the night trying to root down the cause of this threat because the machine learning algorithm said, yes, there is an attack happening. We want to minimize the inaccuracies of these models, and we want network operators to use them and to build trust in them. And the only way that we can do that is by using explainable AI, and developing that advancement, I think, in that very exciting field. So
that's perfect. And now, unless Conor, do you want to make a comment there, or will we move on to the next question?
Well, I'd agree with Donna. It all comes down to explainability, and it's it's a bit like the question Martin asked earlier about the vehicle. Some human has to take responsibility at some point for the actions of these machines. So, the work we've done with the breast cancer detection, we're not trying to replace a human. We're trying to be a second pair of eyes, so that basically the system will highlight an area of a mammogram and say, look, I think there's something weird here. So you need to take a second look at this, rather than saying, there's a problem here, we need to operate on this person immediately. Because it'll be a long time before people will trust, and it'll take time to build up this level of trust as well. But it'll happen slowly, because to make that jump where it's completely automated, I suppose it will take a while before I would trust the machine making decisions like that about me. I'm happy to have this robot vacuum cleaner cleaning my apartment, but I don't want the same vacuum cleaner making decisions about my health.
Yeah, of course. So what I might do is, just based on the time, we probably have time for 2 more questions. So I might pass it over to Sean, just so you can pick one out of the list there.
Yeah,
and then I'll pick another one at random, then maybe at the end.
Yeah, just on a side note, all this talk of Roombas, I'm actually looking into buying one directly after
this
webinar. So the next question is from Ivan. So this is for Conor. So Ivan's question is, evolutionary computing has been evolving a lot in the past decades. Do you think a strong AI could be formed through an evolution process?
Okay, well, so just a little bit of background. So my area actually is evolutionary computation. And it's quite different from other types of machine learning, that you don't have one single intelligent machine that's getting smarter as time goes on. You essentially have a whole population of really weak machines, but they evolve together, so they can mate with each other, they can share their genes, and they slowly get better. Now, I would argue, Ivan, that the answer is no, because it took 4.5 billion years for humans to evolve from nothing. So although maybe eventually, if we set off evolutionary computation on sufficient hardware, then it might be able to pass us out. But based on how long it took us to get to this point, 4.5 billion years, I'd be fairly confident that something else will wipe us out before that happens.
Again, another super positive answer there, because anyone, I suppose that one was really,
well, take your pick of all the things that can kill us.
Yeah, that one was really directed at Conor there. So in terms of the last question, it's more of an open one, and we might go to Luis first. This one comes in from Dermot Hayes. He's asking, is there a moral dilemma in relation to AI, in relation to large companies using AI to profile people and target them for reasons of corporate gain?
I mean, I think that's already happening, right? Every time we go to Google and we press something, it's being quantified, it's being analyzed, and we are the targets of major companies. I mean, we can look at Facebook and other things, and I think really the environment that we know the internet is being under regulated now. It's getting improved over time, But I think we, I mean, I'm thinking about the Facebook because, let's say, about 10 years ago, I used to put a lot of things in Facebook, and I had friends who used to put everything, their whole life there. And it's not just about exposing their life to other people that are not necessarily their friends, but also giving data to Facebook and Facebook selling those things to other. Well, it's debatable, but there's, I think it's kind of, even if you don't actually expose your life through the internet, but if whatever you type on your computer, I believe there's, things are being exposed to other companies and for commercial purpose. So I think things are getting a bit more regulated over time, but I think we're still a bit far away of how things were 20 years ago or 30 years ago. So
yeah, so it's interesting that you mentioned regulation. Like, just to the other panelists then, like, is regulation the answer moving forward? I mean, we've seen Mark Zuckerberg up in front of various different panels and senates and so on. Is regulation the answer moving forward?
Well, it's a combination of regulation and, people need to have a healthier distrust of information coming from these sites. It's because the single biggest problem I think we have at the moment is misinformation. And it's because we're trusting it from a single source, and that source is often set up to exploit our fears and biases. So, regulation is part of it, because the likes of Facebook will only react if they absolutely have to. But until that happens, which it may never happen, then we need to take care of things ourselves. And we do that by distrusting everything unless we have a second source.
Yeah, I think that's very wise, and it's something that we've definitely seen. Just to pass over to Donna there. Donna, I think you had something to add.
No, I think regulation certainly plays its part. I think, like, even just looking at cybersecurity, and the impact that GDPR has had in the EU. Obviously, companies are trying to circumvent that by moving data from EU data servers to US data servers. But overall, the impact of that regulation it protects EU citizens. It protects our privacy. It protects the integrity of our data. But it comes at a cost as well. It comes in a cost of our police forces and our police forces and our cybercrime units not being able to track these individuals as easily, and being able to identify them as they move from state to state. And I think that there are other challenges out there, in terms of not just moral dilemmas in terms of AI, but, backdoors, espionage, all these things are also things that are happening now that people don't talk about, and are reality, So the AI it can be used as a mechanism to solve these things in a very positive way. But they can also have negative impacts. So it all goes down to human society and how we want to use the technology to protect our citizens, and how we want our technology to influence the way that we live. And that's a really big grown-up question that we all need to ask ourselves and take responsibility for as individuals, in the same way that we need to do for climate change. That keeps me up at night,
But it's also, just to jump in, it's also how do we foresee the future required regulation? Because it almost feels like we're playing catch up already. You have these devices that everybody has around the world. So I think it's, do we regulate what's been going on for the last 10 years, or how do we kind of, foresee the future regulation that's required before we know what's, the threats of what's going to happen with that sort of, all that data, and, so. Yeah, it's very interesting.
Yeah, so I think on that note, I think you hit the nail on the head there, Claire. It is very interesting, and what we were talking about, there's so many things there. It was great to see really good positive and negative examples of what's going on, and it's how people, I suppose, moving forward to navigate through those things. Like, this is an event that was intended for lay members of the public to be able to get involved, get some insight into it, and there's definitely some great pieces of advice from how you work with Roombas to how you work with social media as well at the same time. So with that, I want to say an absolutely massive thank you to our three panelists. So Donna, Connor, and Luis. you know, it's a very busy time for academics because everything has had to be put online and people are teaching online. So the fact that you could take an hour of your evening for Science Week to devote it to something like this, we absolutely really appreciate it. The last people then to thank, I suppose, are Science Foundation Ireland. You know, without them, you know, some of us wouldn't have jobs. We wouldn't be doing the research that we're doing, and Science Week wouldn't exist. So there has to be thanks going to them. Last thing then is thanks very much to Claire and Sean for your help. I really appreciate it. That's fine. You don't say you're welcome.
No, thanks, Martin, and just to say thanks on behalf of Confirm to all the panelists and the attendees as well for joining us this evening.
Yep, same here from Lero.
Okay, perfect. So on that note, folks, we'll love you and leave you and let you go. Have a good evening.
Thanks.
Thanks very much, folks.
Bye-bye.
Bye-bye.
Bye-bye.